Welcome. So we're about to start the session. Please take your seats here. I am Miriam. I will be your moderator for today. In-person people, you can have some Q&A afterwards with Nikolai, and anyone online, please put your questions in the FHIR app, and Nikolai will check them later on to answer them. If we have time, I can read them out, but you already told us it's quite a full schedule, right? So if you're ready, Nikolai, go ahead.
Yeah. Hi, everybody. Can you hear me? First of all, it's a real pleasure to be here. I mean, meet people in person. It's been a long time. So can you see my slides? Okay, today I want to talk about the performance. It's interesting. So maybe let's start from my introduction. So I'm Nikolai, so you can find me by this strange name. I'm a passionate member of FHIR community from the early days, as well the Postgres and Clojure communities. As well, I am CTO of Health Samurai. We are building FHIR platform, which intended to build FHIR-first systems. Okay, today I want to talk about the performance engineering, about FHIR server performance. There is a lot of questions about this. How performant is your FHIR server, how it can be performant. And people love metaphors, and the only metaphor I can bring to you is that performance is a rabbit hole. So that means that sometimes common sense doesn't work, conventional logic doesn't work, and why it is. So, okay. Oh, it's a different slide. Okay, we will speak why it is slightly later. So should I care about performance? If you don't care about performance, please don't do this. Yes, because it's a rabbit hole, you will spend all of your time. So don't do it, be happy. It's a non-functional requirement. It doesn't bring you any value. I mean, so you should focus on value. You should focus on flexibility, on serving your customers, users, and so on. Unless you feel the pain, or unless it's too late, like with the security. Like with all non-functional requirements, we see this problem that we sometimes do not put enough attention to it, and then sometimes it's too late. There's some unpleasant phenomenon, which I call accidental death. It's very simple. I try to explain it on fingers. So let's say you are not big applications, so not so much data, not so big load. Let's say you have a database server with the 4 cores, yes? And you just have to serve like few requests per second. So if duration of one request is 100 milliseconds, that's okay. You can serve like 40 requests per second, yes? Everything is good. If you have a bad request, which takes 1 second, then you only can serve 4 requests. If you have very bad request, which takes 10 seconds, then your system is stuck. So you kind of get into denial of service on low load. So, and that's the problem. Probably even if you're not so big, you may encounter the performance problems. Okay, and the performance is hard. As I said, it's a rabbit hole. Why? Because we are on the top of complexity. So if we look into our technology stack, it's crazy complex. So let's say JVM with a JIT and garbage collection, too smart to even understand by creators. The Postgres planner, only a few people in the core Postgres community know how the planner works. So the Linux, and so we are on, and our application, the FHIR is complex. So we're building on very complex stack, and it's really hard to predict what's going on. So, and usually when you guess, you're wrong. When you guess where your bottleneck, you're really wrong. That's why you have to kind of think about this like research, or maybe even detective. So you should observe and measure and monitor. Don't trust your theory. It should be completely empirical stuff. So, and the first step you can start is invest into monitoring things. There are amazing open source stuff like Prometheus, time series database, Grafana, and there are a bunch of exporters. and try to get as much data as you can to understand what's going on in the system. Where is your problem located? Okay, so the general flow is like collect metrics, build dashboards to understand what's going on, and then set up alerts for the future so you can sleep well and only be interrupted when really bad things happen. Okay, and if you're thinking where to start, I would recommend start from methodology, which is called RED or use. There is an open book by Google for SRE engineers, so please read it. So RED is three very simple metrics. So measure requests per second, which is your current load. Is your system under the load or not? So measure error rate, how many requests are rejected. And measure the duration. This is latency of your system. So start from these three metrics, build some SLA, SLO on top of these metrics, and start from here. Then to work on a problem, create some dashboards. They will be essentially driven by your problems. Yes, so collect as much metrics as you can, find the useful metrics, build dashboards, so you clearly, you have introspection into what's going on in your system. Okay, after observe, you can make the next step and move to experiments, like we were in a science field, yes, so it's a black box. All benchmark lies, but some of them useful, I don't know, is it quote or not? But looks like a quote. So, and the first rule you should follow, never just measure just performance of everything, yes? Because, as I said, it's too complicated, so you will spend all of your time if you will try optimize everything. Yes, try to focus on your real load, on your unique scenarios. And the general flow may be like, set up the top-level objectives you want to achieve with your performance, identify the bottlenecks, optimize, measure again, and go back. So start so okay. So what we did the 10 terabytes bench with our partners Innovator. So, and here is a report. I will send you the link. We spent a lot of time. It was really hard because if you have a lot of data, every operation unexpectedly takes a lot of time. Let's say you can just build indexes during the hours. But it was quite successful. So we loaded all of this data. So we set up all the indexes. So we ran the tests, but nothing to compare. Yes, that's why we decided: can we build a bench and build it into our CI/CD pipeline? Can we monitor when we change our system, how it behaves in terms of performance? So it's our dream to create kind of performance test, and we're still there. So, and first of all, you need some bench, some staging where you can measure. Yeah, so we pick this one, and this is a small recommendation. If you go with the clouds, now the prices are quite high. So if you go to the guys who sell the hardware, it may be much more cheaper. So take a look at, for example, to the Hetzner. You see this machine, it's a 22 CPU real CPU, the half terabyte of RAM, and quite reasonable price for that. Don't run your performance test on laptop because you don't want to measure, I don't know, how Chrome behaves and other stuff. So, and it's really hard to work with it. So then we set up the Postgres, and here is a configuration of the Postgres, the best practice. And we pick like 3 servers. The first one is the 8-box, because we develop 8-box, and the 2 others are open source servers, yes, like HAPI and IBM. We trying to do not run all this stuff on Docker or something like this to remove this accidental noise. Yes, so we pick the same JVM, the same Postgres, and these 3 servers, we configure them, like give them all the connection pool to the database to 100, turn it off the logging. This is a common problem, yes. For example, when the conventional logic doesn't work, so in a high-load systems, it's quite often the logging is a bottleneck. So be careful, yeah. Okay, and the first step, if you want to measure something, we want to ingest data. And here we got some surprises. For example, the standard way just generates Cynthia with all these transaction bundles, and in multiple threads load this data through the transaction endpoint. Yes. And at that moment, we realized that 8box is slower than other servers because we're doing a lot of advanced validation, we're doing the conversion, and it's CPU bound, and we sit down and optimized it. So we spent a couple of weeks. So, and you see, but the numbers are quite similar. Yes, it's about 5 hours to load 100 key patches. This is quite reasonable size. It's still load in a day. I mean, you can load this data in a day. You don't spend hours on indexing, but that it gives you some indicators what's going on. So, okay. The interesting fact, which is related to how the servers are designed, is the size of the database. If you look into the size of the database, so the 8box is a smaller one. And maybe later I will explain why it's going on, why it's happening. Okay, but it's still disaster, yes? So we're gonna load millions of records, yes? If we took the hours for 100 key, it's a real problem, yes? You can imagine that you will load during the week. You sometimes think that it's a one-time job, but it's usually two-time job or maybe 3 times job. So can we do better? Can we load faster? Yeah, this is how we optimized our stuff. Okay, sorry. Maybe the general idea that just measure where your system is spending most of the time, find the suspicious piece, try to optimize it, measure again. So, and there's a lot of tooling which may help you in a specific technology stack. Okay, here is a profile which we, by monitoring what's going on when you're loading data, yes? You see that the CPU is quite high, but it's quite performant. What's interesting that the just CRUD operation on most of servers much faster than the transaction operations. And here is the resulting table size in 8box. Okay, yeah. Can we make it faster? Yeah, let's use the FHIR import. So not all of servers implemented the FHIR import, but it gives us much better result, yes? Because it's trade off some pieces like validation of references and other stuff, so potentially you can load 100 key in 30 minutes. And if we had a like 5 key resource per second speed, here we're getting 50. That's much better. And still we have some places to optimize. And here we come to the rule of the optimization, so, which is usually called a trade-off. So you can trade off some features, some functions to get another quality. For example, if we focus on to very quickly load data, so let's take a look what may go wrong. So for example, indexes slow down the insertion. Yes, we use some temporal table for bulk load, so then we double copy data. And the files, ND.json files, are different size, so the rest of files loaded, but the biggest file is still loading, yes? So we can split it in small pieces. We can relax validation and transformation or do it ahead of the loading, yes? And that's how you start thinking when you're doing the performance engineering. You start thinking, what can I sacrifice? What is essence? So for example, in our case, we just want to insert as fast as possible, yes, and we can do the validation and transformation in case of 8box ahead. We can turn off indexing and then build them. That's funny that for when you're inserting with index, it's much slower than drop the index, insert data, and build index again. That's sadly how databases works. Yes, okay, and we did this optimization, we get 8 minutes. And that's reasonable time, yes, and the rest 10 minutes you can spend reviewing all of your indexes. And we get 100 key resource per second insertion speed. But this is a good example how you can do the trade-off and why you should focus on your scenario, yes? So you should look for restrictions which you may put on your scenario and then try to find a solution from it. Okay, yeah, just numbers. So let's say you want to, if the load took the 1 week after all of this optimization and can take hours, just hours. And this is good. Okay, here is the optimization rules or laws I learned from this adventure. So you can try to optimize what you have, and you can get just percent of it, like 20%. We optimize the transaction for the 20%, just straightforward optimization. And it's common case, and if you start monitoring and tracing your system, some performance is spent on some very stupid mistake, very stupid bottlenecks. So if it starts from it, you can just remove this stuff. If you introspect your system, and you can get kind of 100% speed up from it. But the most of, if you really need extreme optimization, then sadly you have to change the algorithm. You should understand your scenario, change the algorithm, and then you can get most of it. Yeah, we look at how we get the even 2-order performance improvement for the loading when we start changing the algorithm, changing the rules. Okay, now let's think about the search. Yes, how we're going to measure the search. First of all, don't just measure average. This is very known stuff, but maybe somebody don't know. So don't measure just averages, because averages works only for normal distribution. Yes, and probably, and in most of cases, it's not your case. So you don't have normal distribution, and the averages may be misleading. So that's why it's better to measure percentile. It means which part of requests, for example, takes this time. Yes. So and this gives you better understanding what is a distribution. Usually it's long tail stuff. Sometimes it may have 2 peaks and other stuff. And you can see that why you should not trust averages on these pictures. Okay, so the next stuff, which is quite tricky, and how to design your benchmarks. So we try to be as realistic as possible. All the servers, I don't know, all the technologists trying to do some tricks like caching and other stuff. Yes, and sometimes you can measure not what you think. You can just measure the speed of the cache. Yes, that's why we tried, for example, we created the random seed for every worker, for example, which is getting random data from the real database, and then run the FHIR request with the different patient names, with the different patient IDs and the codes. And this gives you more realistic view what's going on. So yeah, so we designed the many, as well we are measuring on a different number of threads. Yes, because usually your performance should degrade with the load increasing. But for sometimes it may work like linear, and you want to see this. So the workers getting the seed data, then building the request to the server, and then at the end they build the report. So we wrote this with the code. So initially we querying by SQL all the servers, getting some random data from it, and then seeding them to the workers. Workers just template request, put specific value in it, and then measure the time. Okay, and I forget about the total. Yes, it's a real problem. So I mean, turn off the total. If you expect some lower, turn off the total on your server. Sadly, it just doesn't work because you pay for 2 queries. You pay for the query for the data, which is valuable, and you pay for the query for the count. And sometimes query for the count is more expensive than query for the data. Then, sadly, this is true. So that's why we introduced this underscore total, at least be one of them who introduced this underscore total parameter into the search, and you can turn it into none. And here is, for example, results. Can you see the numbers? Yeah. So the results for search patient by name and the comparison. So, and you see that sadly, I don't know why Happy and IBM quite slow on searching patient by name. So, and I think this is a kind of quite common scenario, and guys, you can optimize it. So And you see we measured it, so we will eventually publish the full report, so you will be able to go and see all these numbers more precisely. So, okay, so let's search patient by identifier. So for example, for identifier, the most of FHIR servers behaves quite well. So you see that we measure the mean time, you see the mean time graph as well, you see the throughput, like request per second graph, and you see the table with all the percentiles, means, and deviations. Okay, the birth date, again, you see that, you see a lot of interesting stuff when you start doing this. Okay, this is just the samples. Okay, another very interesting operation is very common, just get observation by patient ID. Again, we're getting kind of similar numbers. And we try to measure includes, for example, and most of servers behaves very well because the implementation is quite straightforward. So there is a lot of penalty when you're doing some inclusion. So, but now, let's go deeper and try to understand how it works, because this is really required. When you're trying to optimize some performance, you should understand what's going on, how it works. You should have some hypothesis, some model to tweak. So for example, the HAPI store everything in a resource table, and then it's create for specific parameter types, specific tables, and put indexes on it. And now you can guess why the size of the HAPI database is so big, yes? Because they kind of store the same data 3 times. Once in a resource, second time in a parameter table, and third time in an index. So, and on the right upper corner, you see the kind of SQL which is generated by HAPI to search through 2 parameters, yes? And it's forced to be joined. Okay, IBM doing the same, but they kind of partition by resource type. So you have a patient table, and you have dedicated tables for patient parameters, and as well indexes. So but it's done slightly more efficiently, I mean in terms of database size. 8box took completely different approach. So we just store as a native binary JSON in Postgres patient in a specific table. We don't do any normalization, I mean denormalization of search params. So we're using the Postgres capabilities to work with this data. And we just create indexes. So essentially we kind of store it twice. Or it will work even without index. It may be slow, maybe not, but you even could not create the indexes. And we are kind of building different, we're just building the query on this table using Postgres features to access elements in a JSON. And if you look into the HAPI, for example, in IBM, the shape of the query will be the same, because it's quite straightforward. With 8box, it's not the case. You potentially can reformulate your query in a different ways, and then bring us to that you can change the underlying SQL for the search. And that means that sometimes when you go deeper, you can use different indexes. For example, you can just do very simple stuff. You can extract specific element and make the bad-tree index on it, which is well-known, well-behaving stuff, but you should create such index for every pass, every parameter you want to search, yes? Or you can use a gene index, and you can index the whole resource, and then one index may serve multiple different queries. But gene index is bigger. When you build gene index, it's much slower. It cannot be parallelized like bad-tree, for example, but it serves multiple different type of queries. And here again, we're in the field of trade-offs. What should we pick? Just build tens of bad-tree indexes, or build one gene index, yes? And things even getting worse. So, but we try to measure it. So we tried, for example, search observation by patient using bad-tree index and using gene index. Yes, gene index is reused by other type of requests, and bad-tree indexes serve only this specific request. And we see that bad-tree behaves better, yes. and the gene index is really capricious, and you should work on it somehow. So that brings some complication. If you, for example, compare the 8-box with the HAPI, you can install HAPI, you should not do anything because everything is indexed, yes, but you have a limit of the performance, yes. It will always behave this way, yes. With the 8-box, you have to start thinking what kind of index, what kind of expression. So it's much more complicated, but you can get more performance from it. And so we took this approach like ordinary, I don't know, DBM database administrators do. Yes, so indexes are optional, and it's a matter of the law to pick the right indexes and maybe drop not used indexes. It's much harder, yes, but you can get the maximum from it. Okay, this is kind of synthetical example when I just try to break everything, yes? So if you understand how it works, you can do this. So for example, the HAPI and IBM doing the join. Join works well if you have a very selective criteria on one table. Then the database starts from this criteria, take few records, and just doing nested loop and getting all the data by index. But let's imagine we have a query which has two expressions, but they are non-selective, and they have very narrow intersection between. So that means this join will cost a lot for you. And if you try to measure this, yeah, you will get a problem, even with the 8-box, yes? You see it's becoming the second or half second. But again, you can trick it. So here is the numbers. So you can rewrite in 8-box, you can rewrite the query and build what's called composite index. That's something new. You can build index on multiple columns, on multiple expressions. It will serve only this specific case, but it will be very, very, very efficient. You can go here and see it's again, tenths milliseconds instead of seconds. And sadly, what I've seen from my experience that database are not so good as you think. They quite stupid machines. So they do that. So yeah, they have problem with joins. They have problem with the sorting. They have a lot of problem with index composition. Naively, you're thinking that if I build index, everything will speed up. No. If you have complicated query with multiple criteria and multiple indexes, it's not the fact that the database planner will took your index, even if it's worked well. And it's really hard to force it to use it. So, and my rule, if you want to get extreme performance, you should only hit one index. That's how you can get to the milliseconds request time. But this needs some performance engineering, requiring queries and all this stuff. But you can do this, but you will spend the time. Yeah. Again, trade-off. You will trade off your working time for this extreme performance. And here come other ideas. So if you look into the FHIR specification, it say you can do any search parameters, any combinations, and any stuff. But guys on the high load start complaining. They say we could not optimize all possible these combinations. And somehow we should start thinking about how we can put some restrictions on the FHIR API. And this restriction may be quite tricky. Not we just serve this search parameter or not. Yes, we may serve combination. We may serve, for example, we may need required parameter. Like I said, if you have a selective criteria on your search, then the rest will be fast. So potentially you can allow the all possible combination if you put patient parameter on observation. It will work in a good time. So that means that we need some tools to express that. For example, for this API, you're forced to use patient search parameter and then the rest of parameters, any combination. Or it is specifically optimized by pair of parameters, yeah, or some composition of parameters. And we like this in FHIR specification, but I mean, these requirements are growing from real usage. Another interesting parameter which may save us from this accidental death, when you have bad requests, yeah, it can just stuck your server completely. And so, for example, in 8box, we introduced what's called a timeout. So if the client know that it wants this result in this specific time, because database is honest. If you give it the request, I mean the query, which may run one day, it will run it one day. So, and and you very quickly eat all of your resources on database server. But potentially, so you can do kind of this interaction with your clients. So if they know that they only need this in a specific period of time, I mean, they can set the timeout. It's okay if one query, if one request fail, but the rest will work, other than you send 10 requests and then deny any others, yes? So there may be some smart stuff we're still thinking, maybe some algorithm which can dynamically adjust this timeout parameter for different type of queries, but here we're getting to this real world of performance trade-offs, yes? So let's penalize the slow queries, but the quick, let them work, yes? Some type of quotas, yeah, but I suggest this underscore timeout parameter, which may help in the performance optimizations. Okay, so there is no silver bullet. There is no FHIR server which will serve all the requests quickly, yes? But there is a performance engineering, and it is a process, it's not one-time stuff. So monitor your load, identify the slow stuff, and then start thinking how you can solve this problem. Build some specific index, rewrite the request. Sadly, that's how it works. So you need a dedicated guy who will make your system work efficiently. You can get very amazing results, like 2-order magnitude kind of speed up, but this requires a lot of smart work. Okay, so what we're gonna do next is our plan. So I started like 4 months ago, deep dive into the performance, and I'm still there. So we want to build the bench, and we want to build a performance test and identify the performance bugs, and build it into the CI/CD pipeline. So let it run every night, because every commit may break your performance completely, and this will bring that to denial of service on your production. Yes, and eventually we will publish our result in our bench, so everybody welcome to, I know, do some ideas, add some ideas to this benchmark, or maybe use it on their server. So, and I think that's all from my side. Yeah. Any questions? Thank you, guys.
So on the underscore total, turning it off, you're talking at a FHIR request level, and so you're saying when I go get my patients, don't go get the total, include that. Will you go back to where you say turn off the, you said turn off the
I mean, if you want
total.
to get the extreme performance, yes, I would recommend to do this. There are some tricks when you can kind of estimate the total, yes? It's not going to be the exact,
okay.
But
So
again,
when you were doing that, was
yeah.
that a part of the paging process, or was that part of getting all, or your request for the patients was all of the patients and the total? I was a little fuzzy on like how you're turning off the total, what it means in the actual response.
Okay, thank you. So that influences the design of your interaction of the client with the server. And maybe not a lot of people know, but the limit and offset, it's a trouble for the database. So the database is okay to give you a huge piece of data very quickly than doing this paging. So and you have to think, do you need the paging? Can you replace the paging with just a search when you're getting this result? So and can you get rid of these counts? So, and again, it's a trade-off. So everybody wants this count and nice paging, but it doesn't work in the performance world very well.
All right, that cleared it up. Thank you.
Thank you.
Awesome. And if you look at the latest build of the FHIR spec, the search page has documentation for that same total parameter that Nikolai was showing. This is an awesome presentation, Nikolai. Thank you. I'm curious, when you think about the point that you raised about communicating different constraints. You say, well, we know that, if we optimize our server right, we can support these combinations of parameters, and if you include a patient, then it's selective enough that you can also do these other things.
Yeah.
So it makes total sense to me that you might want to document an API that expresses all the things that you know you can support in a performant way, and prohibits a bunch of things you know you can't support in a performant way. How important is it to express all of that in a computable, structured, data-driven way versus just, having developer documentation with a whole lot of bullet points that says you can do anything that looks like this, or you can't do anything that looks like that?
It depends, yes. I don't know, do people read the documentation when, what we see, they go and read the FHIR search documentation, then the load like at tens of millions patients, and then come and here, it's slow. Sorry guys, we could not make it faster.
But your examples looked a lot like US Core, for example, where we say, like, we only call out 5 search parameters, and we say, these are the 4 combinations that need to work.
Yeah.
Like,
yeah, that's exactly.
Is that okay? Like, should we have more infrastructure for being able to express that computably? Because in US Core right now, it's just a bullet list, pretty much. I mean, there's a little bit of structured stuff underneath, but I don't think anybody ever reads that.
Yeah, and I expect there are gonna be requirement for this when we're getting more and more real servers under the load. Yes, you will be forced to do the same like US Core do, and it would be nice to have some tools in a FHIR toolbox to express that this parameter is required, or we only serve this combination, or the sorting is restricted. You could not sort by any parameter you can search, so you can only sort by specific parameters.
Awesome, thank you.
Yeah, thank you.
One more question.
Just super quick, the happy combination that you used was the open source happy with the simple JPA setup. It wasn't the Smile CDR.
Smile CDR is closed source. So I hope when we publish our bench, so the Smile can run the same tests.
Thank you.
And we can compare. Yeah.
Thanks for the presentation. Firstly, it was very helpful. I just wanted to ask you that what's your take on looking at the database more from the microservices architecture point of view, like something using CQRS and creating a read replica, or taking the change data capture and putting it into a database which is more optimized for reads, and keeping these two separate and not have to address some of the challenges that you mentioned, where the writes are going into that master and then, the other ones are replicated and used for query purposes.
Yeah, that's possible when people do this. Yes, if you look into FHIR specification, it's still essentially kind of expect some ACID database behind. So when you do the creation, there is no way to say you can read this resource in a second. Not right now, yes?
In the latest draft, there is.
There is, okay, so you can kind of, okay, yes, and again, it's a matter of trade-offs, yes? So we are building kind of backend for EHRs where guys expect this conventional logic. If I created something, it's appeared right now, so you can kind of search for it or read this resource. But if you're doing really huge installation, yes, that's only the way you can do. So you will do some event sourcing, CQRS, create the special databases, index and elastic, yes. But this, again, yeah, you just push this, it's your contract with the client, yes, of your API. So you can say, if you create it, just wait a couple of seconds, maybe this resource will appear. And this may work in many scenarios, this really may work. Yeah. Or you may have 2 APIs, one slow, which is transactional, and another which is quick, but not transactional.
There are some questions online as well. So just a quick one here. Is the test data that you loaded something that might be publicly available?
Yes, that's our plan, as I said. So initially we want to focus on we want to bench internal, create the internal bench and run performance tests and CI/CD, and we're definitely going to publish the framework. So, yeah.
Okay, thank you. Do you believe that we can gain performance by migrating to a NoSQL database?
What the name of the database?
Just a NoSQL database?
Yes. So again, it's a matter of trade-off. For example, with the most of NoSQL database, you sacrifice transactional consistency, at least through multiple tables, but they gave you kind of better scaling out of the box, yes, and better performance. Let's say Elasticsearch. It's not transactional index, yes? So you sacrifice this transactional read, but because Elastic decided that it can bundle all in these blocks, and it can do it faster. It can do faster search.
Okay. Well, if anyone from the room still has a question, come up. But I have 3 more, I think, in the so if no one comes up, then I'll continue with these. So how do you approach what validation you prioritize and choose not to check for to improve validation performance?
Can you say it again? Sorry.
How do you approach what validation you prioritize and choose maybe not to check for to improve validation performance?
So as we showed in the load example, yes. Yeah. So sometimes you can do it ahead of time, and it really depends on the scenario. So as I said, the create on most of servers much faster than transaction. So you can imagine that you can load all the data through the create. But at that time, the referential consistency is going to be broken, yes? And for example, for this scenario, you may imagine the parameter to turn off the reference validation. Sometimes you want to turn off the terminology validation. Sometimes you just want to turn off the complete validation because you trust your data, yes? Or you want to do it later.
Do you believe FHIR inherently has performance limitations due to the verbose nature of the JSON and XML structures? If we have real-time requirements, do you think FHIR would be a good choice?
FHIR doesn't force you to do everything. Yes, FHIR quite optional. So you can only implement the kind of performance pieces. Yes, just a few parameters, as we said. Yeah, but I would say that FHIR has performance challenges, which is interesting to work on. So let's say like chained parameters. Yeah, it's going to be joins. And if you want to use multiple chained parameters, okay, so you are in a problem.
Let me see.
But no one say that it's unsolvable. Yes, as I showed, sometimes you can find a very interesting way to make it very performant.
Okay. No one stood up yet. Looking at Sloan there. Did you test performance of working with full FHIR JSON objects in Postgres instead of the normal column-based approach?
I don't know what means normal.
Me neither.
Yeah.
I don't know Postgres, but you mentioned that you had the full JSON.
Yeah, we are using binary JSON in Postgres. They support JSON, I think native support JSON in Oracle and MySQL. So most of relational databases starting supporting it. It's still in progress, but it's open a lot of possibilities. If we're talking about FHIR, doesn't fit very well into this kind of flat fixed tables because it's too generalized. So, and maybe like 10 years ago, we tried to generate the normal model of the FHIR, and we get kind of thousands of tables. So, but yeah, if you already have something relational and optimized, you can kind of build a restricted FHIR API on it. Yes, so you don't accept any additional identifiers, you don't accept any additional extensions, and it may work, it may serve your cases again.
I think I might be able to translate that question a little bit. So with your Postgres setup, you're using a JSON binary column. Do you have any extra tables and columns that are like search parameters that are pulled out of that JSON? It's completely
that's the general idea of 8box. Yeah, we don't duplicate data.
Okay.
Yeah, only indexes can duplicate this data. Yeah, that's why the small of database is so small. I mean, size of the database is so small. But you have to build indexes, and sometimes, as we discussed with the Google guys, the size of indexes in Google has much more than size of data.
Okay, thank you. That's the end of the time that we have. So thank you so much, Nikolai, for
Thank
this
you.
presentation.